So in this example, we are given a differential equation, y primed equals negative x divided by 4y, and we're asked to sketch the direction field and solve the differential equation. So let's start by setting up our little graph here for our differential, where we're going to do our slope field. 1, -1, 1, and -1 right there. And to do our direction field or our slope field, we are going to pick some values of x and y and figure out what the slope of the tangent is. Now the first point we would probably pick would be 0, 0. If we sub 0 and 0 into our differential equation, we end up with 0 divided by 0. What is 0 divided by 0? I'm not exactly sure. So let's just leave that point and pick a different point. Let's pick a point, let's keep x equals 0 and y equals 1. So if we sub in x equals 0, y equals 1, we get negative 0 divided by 4. So 0 divided by anything is still 0. So in fact, we can kind of generalize this, that anytime if x is 0 and y is sort of any number at all, we are going to get a slope of 0. So slope of 0 means a horizontal line. So at 0, 1, put a horizontal line. 0, -1, put a horizontal line. We'll put one up here at 0, 2, and 0, -2. And I'm going to leave that point 0, 0 still, because this pattern here seems to suggest that we should have a horizontal line there in the middle, but we're going to kind of leave it. So now let's pick something different here for x. Let's pick x equals 1. Let's choose y equals 0. So if we sub them in, that's 1 divided by 0. Anything divided by 0, though, is going to be undefined. So an undefined slope is going to be a vertical line. Okay, slope of 0 is horizontal. Okay, undefined slope. So if we choose anything at all for x and y is 0, we are going to get something that is undefined. So anywhere along this x-axis, we are going to get vertical slopes. Well, what if we move off the x-axis and the y-axis and pick some different sort of things here? Let's pick x equals 1, y equals 1. That's going to give us a slope of -1/4. So let's draw that in. It's kind of like that. And then let's move down to x equals 1, y equals -1. That's going to give us a slope of +1/4. So similar sort of angle, but just going in the other direction, kind of like this. If we go over to x equals -1, y equals 1, let's see, that's going to give us 1/4. So it's going to kind of go like this. And if we choose -1, -1, we are going to get -1/4. So something kind of like that. So we might as well fill in, let's see, our 2's as well here. X equals 2, y equals, let's choose y equals 1. So if x is 2 or y is 1 and we sub them in, we get 1/2. So that's going to be a little bit, let's see, 2, 1, hold on, let's double check that. X is equal to 2, y is equal to 1. Oh, sorry, that's going to be -1/2. Good. Forgot about my negative sign there. So negative and sort of a little bit more steep. Okay. So if we look at these slopes going across this line, x equals 1, going this direction, we see it starts off somewhat steep, gets less steep, goes to 0, then it becomes negative. So it's going to get, by that pattern, we can see it's going to get a little steeper over here. Okay? And we can look for patterns going down, up and down as well. So here we see it, if we look at this line going down like this, okay, we see it go somewhat steep, undefined, back like that. So it's going to be less steep, kind of coming down here like this, and sort of less steep the other way, kind of like this. And we can keep calculating points, and we can keep sort of filling in our direction field, or just sort of recognizing these trends. This is going to be steeper like this, and so on and so on. So the pattern that we see looks kind of like we've got sort of a circular or an oval shape here in the middle. These things are kind of going sort of around like this, or around like this. Okay? Let's see how this compares to when we solve the differential equation exactly. So our differential equation here is dy dx equals negative x over 4y. How do we solve this? Well, this is a separable differential equation. We can bring all the y terms over to one side, x terms over onto the other side. So we do that, and then integrate on both sides. So we're going to be integrating 4y dy and negative x dx. So if we integrate on the left and the right-hand side, we're going to have 2y squared, negative 1/2 x squared, plus a constant of integration, where we've combined our two constants of integration into one constant of integration. And now we want to solve this thing for y. Or can we? Well, let's just sort of bring both the x and the y over to one. No, let's see. Let's start solving for y here. Let's divide everything by 2 to get y squared equals negative 1/4 x squared plus, and then our constant divided by 2. And then I'm just going to sort of bring these x terms over, and I'm going to get y squared plus x squared divided by 4 equals, and I'm going to take this constant divided by 2, and I'm just going to say it's equal to another constant. What is this the equation of? Well, this is the equation of an ellipse. Oops, that's not how you spell an ellipse. And I should say it's a series of ellipses. Centered at 0, 0. So basically, if we change the value of that constant, c2, it's going to change the radius of our ellipses. And so that's exactly what we see in this direction field. We've got a series of ellipses. These aren't quite circles, but they're ellipses. And if we choose different values for that constant of integration, we'll get different radii for these ellipses.